Okay, now we're going to be doing rind with problem A, which is 3 base 5 times 4, 1 base 5, which really means that there's 2, 3, 5 base 5 groups of 4, 1 base 5. So we start out by doing one group of 4, 1 base 5, which is equal to 4, 1 base 5. Then we double it, so we have two groups of 4, 1 base 5, which is equal to 132, or 132 base 5. Then we double that, so we have four groups of 4, 1 base 5, which is equal to 214 base 5. And then we double that to 8, or 13 groups of 4, 1 base 5, which is equal to 4, 2, 3 base 5. And then that's the largest we can go. So now we need to get to 23 base 5. So we're going to have one of the 13 groups of 41 base 5, two of the four groups of 4, 1 base 5, and two of the 1 groups. So this adds to being 4, 1 base 5, 4, 1 base 5, plus 4, 2, 3 base 5, plus 2, 1, 4 base 5, plus 2, 1, 4 base 5. And then we add that all together, and we get 2043 base 5. So now we need to check it in base 10. So I've already converted 23 base 5 to 13 base 10 and 4, 1 base 5 to 21 base 10 and multiplied them to get 273. So now we take 273 and we're going to subtract it by, we know that the large cube in base 5 is 125. So we subtract 125 to get 148, and we subtract another 125 to get 23, and then we subtract 5 to get 18, and then we subtract 5 to get 13, and then we subtract 5 to get 8, and then we subtract 5 one more time to get 3. And then we know that we can't subtract any more 5, so those have to be small cubes. So we count out how many times we subtracted the large cube, and we have 2. Then we subtracted rods. We didn't subtract any flats, so there's a 0 there. We subtracted 1, 2, 3, 4 rods, so 4 goes there, and then we have 3 small cubes left, which we know is equal into base 5. So that proves that our answer is the same as above.